When we discuss power of an AC circuit, let us start with the situation in RLC circuit. Applied EMF is E equal to E0 sin omega t. Then voltage across the resistor we know VR. We have taken as VR, this is VL, and this thing is VC. And if we draw the phasor diagram by assuming that VL is greater than VC, then phasor diagram going to be like this, that this is VL, assuming that this one VC and this one VR. Never use arrow sign. And the resultant of VL and VC will be along the y-axis only. That we have taken VL minus VC, and this one is VR. This part is VL minus VC, and tan phi, that is the voltage lead current. You know, current is also taken along the direction of resistance. Tan phi equal to VL minus VC by VR. VL is in the circuit, VL will be I nu into XL. You can take RMS value, you can take the maximum value. I nu into XC, and this part is I nu into R. That is XL minus XC by R. Okay? Resistance, inductor, capacitor, and this is the applied EMF. E equal to E0 sin omega t. Because along the resistor, that current, and if you take maximum value of current is fine, or the RMS value, that I nu and VR in same phase. For inductor, you know, the phase of these two, that VL and VR, or VL and the current, that will differ by pi by 2. I mean, voltage leads current. I nu and VR is taken along x-axis only. This one, the current leads EMF. So if we have taken, this is the direction of current, that is VR or I nu or IM, whatever, then this is going to be the direction of VC. This is all you know. What I want to say, if we start with this expression that tan phi equal to XL minus XC by R, then in this diagram we have taken I nu, current in this direction, and voltage, the resultant voltage, I mean difference between VL and VC along y-axis. And that tan phi going to be equal to what? And what I want to say, that phi, about the phi is the difference between, phase difference between the voltage and the current. Current you are taking along x-axis. This is phi, we have already taken tan phi. This means phi equal to tan inverse XL minus XC by R. So there is a difference between the phase of the voltage across the inductor capacitor and the current, that is phi. In any AC circuit, the applied EMF, if we take this manner, Nu equal to E0 sin omega t and I nu equal to I0 sin omega t, this will not be appropriate because voltage and EMF, they have a phase difference. I mean current and EMF, they have a phase difference. In this circuit, VL minus VC, this thing leading the phase of current by tan inverse XL minus XC by R. So, when we have a general discussion on EMF and current in AC circuit, we should consider a phase difference between these two. Let it be phi. Okay? So let us start from here. Let current in AC circuit given by this and voltage in AC circuit given by this. You have taken Nu equal to E0, this is RMS value, and I nu also RMS value. Now, can I say that the power of AC circuit is like DC one, P equal to V into I in DC, P equal to V into I. But here, can we write P equal to E nu into I nu? No. You can't write P equal to E nu into I nu because this power then going to be changed to it the value of T. T is changing. So this cannot be the expression for power in AC circuit. Then what you have to do? To find the power of AC circuit, we define as the average power, because all these instantaneous values, if we consider, then power is also changing with time. We want to calculate average power dissipated in AC circuit. Instantaneous value doesn't help because over a complete time interval given, we have to calculate average power, and that we can do over a complete cycle. So we define average power this manner: average power equal to work done by AC voltage in complete time interval. Time interval, you know, T equal to 2 pi by omega. In a complete time interval T 2 pi by omega. So work done by AC voltage in time T, that divided by the length of time interval. This is the average power. But work done by AC voltage in time T, how to find it? For that, we will find work done by this formula, that is Nu I nu into, in a small time interval, work done will be dt. Understood? Because work done is equal to work done, you know, power into time. Okay? Work done equal to power into time. So that power is in you, I knew. And we are taking a small time interval where these two instantaneous values are not going to change. In you, I knew for the time interval dt, because dt is very small, will remain the same. So we find work done in a small time interval dt. Then we integrate over the complete time interval t and then divide the result by d. Hope you have understood that P average. So P average will be integration of E nu. What we have taken the value of E nu? That is E0 sine omega t plus phi. And I nu is I0 sine omega t dt, that divided by the value of t is what? That will put definitely it is t now. T is 2 pi by omega. Now we need to integrate this expression by keeping E0 I0 by 2 outside, 0 to t 2 sine omega t plus phi sine omega t dt, that divided by t. This one is E0 I0 2 sin A sin B is cos A minus B. This one A, this one B, minus cos A plus B into dt, that divided by t, 2 pi by omega. Here also you put the value of t here, that is 2 pi by omega. Okay? So P average will be E0 I0 omega 2 into 2 pi, and this thing after integration cos pi into t 0 to 2 pi by omega minus sin 2 omega t plus phi by 2 omega 0 to 2 pi by omega. Okay? So let us simplify it. P average going to be E0 I0 omega by 4 pi cos phi 2 pi by omega, and this thing will be sin 2 omega into 2 pi by omega t, that is phi minus sin phi, you put t equal to 0 by 2 omega. Okay? So this will be E0 I0 omega by 4 pi cos phi, this thing is what? This is minus E0 I0 by 4 pi 2 omega, this omega getting cancelled, sin 4 pi plus phi is sin phi minus sin phi. Okay? So P average will be E0 I0 by 2 cos phi. This is the final expression for average power of AC circuit where the voltage leads current by an angle phi. Okay. Now we'll find power of AC circuit containing R only. Containing R only, resistance only. In that case, you know, this Nu, I are in phase. In phasor diagram, there is no phase difference between them, so phi will be 0 degree. Then P average will be what? Just put the value over there. P average will be E0 I0 by 2, and if it contains a resistor only, then the value of I0 will be E0 by R. We have taken the maximum value here. Finally, we got the maximum value there, that's why. So put this value E0 by R divided by 2. So the value is E0 square by 2R. This is average power in AC circuit containing resistor only. Now, AC circuit containing C only. If you go by the phasor diagram, we need to remember the value of phi. If you don't remember it, then phi will be pi by 2 here. This is the direction of what? I0, I knew, whatever you say, and this is the direction of E0. So P average in this case E0 I0 by 2 cos pi by 2. The value will be 0. No average power loss is there in AC circuit containing capacitor only. AC circuit containing AL only. AL only means that I0, if you have taken along x-axis, E0 will be along y-axis. Here also phi is pi by 2. So P average will be what? E0 I0 by 2 again cos pi by 2. So average power in inductive circuit, only inductive circuit, is also 0. Then we consider LR circuit. For LR circuit, inductor resistor. I just remind you the value of phi here. This is L, this is R. E equal to E0 sin omega t, and then this is VL, this is VR. In phasor diagram, we take VR and I in the same direction and VL this manner. In you at any instant, the RMS value of EMF is the vector sum of these two, and you know tan phi equal to VL by VR, but this VL is I nu into XL divided by I nu into R. So tan phi will be XL by R. Therefore, phi will be tan inverse L omega by R. Okay? The value of phi will be tan inverse L omega by R. So P average will be what? E nu I nu cos phi. In this impedance triangle, this is phi. This part is XL and this is R. So tan phi is XL by R means cos phi you can find. This side going to be XL square plus R square. So there it will be E nu I nu R by, this is called impedance, J is equal to XL square plus R square, and I nu equal to what? E nu by Z. So E nu by Z, and this is also Z. So there it will be E nu square R divided by Z square.
So that by 2.
So E nu square by, yes, E nu, I nu, actually I have this P average expression we have seen E0 I0 by 2 cos phi. So this is nothing but E0 by root 2 I0 by root 2 cos phi. E0 by root 2 is what? E nu I nu cos phi. Okay? So that's why I am using the expression. Not wrong. E0 by root 2 is E nu, RMS value. I0 by root 2 is I nu. I am putting it there. You can do it here also, no problem. So this is going to be E nu square into R divided by XL square plus R square. So average power will be E nu square R divided by XL square plus R square. Okay, clear? For shear circuit, if we want to find average power, capacitor, resistor, input EMF, this is C, R, and if you go by phasor diagram, actually in this case phasor diagram will take with different manner. See, you take the same way because current will be taking this way, then is fine, and this is XC, this is phi, tan phi equal to what? Tan phi this is VR, that tan phi will be R by XC. No, this will be XC by R. So we are drawing a wrong diagram over there. You better take this way. This is R, this is R XC. In this triangle, as it lags, in triangle you need not put the arrow. This is R, this is XC, and this is phi. Because in this direction VC is there, in this direction VR is there, VC lags behind the voltage of resistor by phi, and tan phi value is XC by R, 1 by omega C into R. So P average formula we apply here also. P average will be E nu I nu cos phi. This is E nu by Z, and the value of cos phi is R by Z, because here the hypotenuse Z is equal to so there it will be by Z square. So P average will be E nu square R by XC square plus R square. This is the value of average value of power in AC circuit containing capacitor and resistor. What will you get in RLC circuit? Resistor, inductor, capacitor. R, XL, XC. And tan phi, you know, XL minus XC by R. In the beginning, I have discussed with you, phi is this. So in an impedance triangle, this will be what? That is impedance, R square plus XL minus XC whole square. So if you find the average power for RLC circuit, then it will be E nu E nu by Z cos phi. What's the value of cos phi? That is also R by Z. So E nu square R by Z square. That is E nu square R by XL minus XC whole square plus R square. Hope this you have understood. Average power of AC circuit containing RL and C. In fact, if you remember this expression for a numerical calculation, then this is general one. If you take shear circuit only, put XL0, you get the average power. If you put XC0, I mean where there is no capacitor, then average power will be E nu square R by XL square plus R square. Okay? So this average power you try to keep in your mind for numerical calculation. Now in this context, I would like to state what is wattless current. What is when the current is said to be wattless, not worthless, worthless. Worthless also. Some extent it is worthless also. Why the current is said to be worthless? If we go by this phasor diagram where phase difference between E nu and I nu is phi, and you write average power, then P average is what? E nu, I nu, cos phi. Okay? Phi is the angle between E nu and I nu. These are vector quantities in phasor diagram. Suppose this I nu, we resolve I nu into its two components. What are the components of I nu? We resolve it along E nu as I nu cos phi. We resolve it perpendicular to I nu. My God, that is I nu sin phi. Okay, these are two components of I nu we have resolved along E nu and perpendicular to E nu. This part is made mathematical. Now, if we use the same expression for average power due to the component E nu cos phi, average power due to I nu cos phi, E nu will remain as it is. E nu, this thing I nu cos phi, and I nu cos phi along E nu, so angle between them is 0 degree. This is going to be E nu, I nu cos phi. Hope you have understood. And then we calculate average power due to I nu sin phi. There will be P average 2. For that sin phi we are going to find P average 2. It will be E nu as it is, but I nu will be I nu sin phi, and what's the angle between I nu sin phi and E nu? That is 90 degree. So this thing going to be 0. What do you observe here? Average power due to I nu cos phi, P average 1 is nothing but P average. Isn't it? That is average power, what we have got earlier, P average. But due to this thing is going to be 0. So what is your comment about I nu sin phi and I nu cos phi? It seems that I nu sin phi has no contribution to the average power. It is due to I nu cos phi only. That's why the component I nu sin phi to be referred as Wattless component of power. No, Wattless component of current. Okay? So, it is based on their contribution. Contribution as if that I nu cos phi, its value, its contribution is responsible for the whole of average power generation in the circuit. I nu sin phi has no contribution. That's why I will be referring this one as Wattless component of current. Hope you have understood.